Hey guys, so today we are going to be doing a more practical example using Cilk. This is going to be video number 6 in the Cilk Plus tutorials, or sorry, video 7 rather. And we're going to be doing a sieve program, which is basically, if you're not familiar with the concept, it's basically an algorithm that allows you to calculate prime numbers. Um, it basically starts out by initializing an array of all the numbers, and it starts off at the ones that it knows are prime, and it removes any numbers that are multiples of that prime number. So then it knows that if 2 is a prime number, any multiple of 2 is not a prime number. If 3 is a prime number, any multiple of 3 is a prime number. And then it'll check 4, but 4 is already marked off, so it'll go to the next one, it'll go to 5. It'll say, okay, so if 5 is a prime number, any multiple of 5 is not a prime number. And it'll keep on going, recording the prime numbers as it goes along, and eventually it'll get to the end, and you'll have your list of prime numbers up to whatever size you want it to be. The reason that this is a very fast algorithm, but it's not exactly space efficient because you do need to store every number from 1 or 2 all the way up to the number that you're looking for. So if you want the list of prime numbers up to 10 to the, I don't know, 18 or something, it would be very difficult for your computer to have that much, like, it's hard to get that much memory in order to run this algorithm. So anyways, if you go to Wikipedia and you type in Sieve of Eratosthenes, you'll basically get the algorithm right here. I already went ahead and made a Visual Studio project of this, and I've already made the array of booleans using the array notation. So we are making use of vectorization when we're initializing our array. And then here is the actual example. Here's the actual algorithm for the sieve. And then when it's done calculating it, it'll just clear the memory and set the pointer to null so that we don't have any dangling pointers. So basically, if we run this, it'll just run in serial, no parallelism, and then I've got 3 other parallel examples. So if we do the same thing except with a Cilk for. So here's the for loop up here. We'll just change it to a Cilk for, and then there's this guy, who instead of a Cilk for, we're going to use more array notation. So this is all going to run in one thread. So it's basically, it should be serial sieve B, because it's doing everything in one thread still, but it's making this guy go SIMD rather than Cilk for. And then in the third one, we're doing both SIMD and Cilk for. So we're just going to go ahead and see how each of them performs based on our timing right here. So right now I've got the timer set up for sequential sieve. Okay, so we're going to want to include the math library so that we can use exponents, and go ahead and run sequential sieve. And 0.94 seconds, so basically 1 second. Now if we change this to parallel sieve A, save and run, 0.68 seconds, so it's already getting faster. I'm actually going to go ahead and clean this up a little bit so that we could do it all the calls at once. Where it goes sequential, A, B, C. rid of the declarations. I'll be posting this file in Dropbox in the description, so you could actually download it and test it yourself too. But yeah, here goes. Okay, so we can see that the serial version took about 1 second. The parallel version using Cilk for loop took about half a second. The parallel version, well, I guess serial version, instead of a Cilk for, if we use SIMD instead, it's close to a second, but not as slow as the serial version. So we are getting a little bit of speed up in terms of the fact that we're using SIMD operations. And then the one parallel Sieve C, the one where we're doing both the Cilk for and SIMD operations, is actually executing faster than if we just use the Cilk for. So we can see that we're getting over 2 times the speed up using both SIMD and Cilk for rather than over series. So yeah, I'm going to be posting this. I'm going to be posting this file to Dropbox so that you guys can download it and check it out. The differences between these guys is simply changing the for loop around. For the SIMD stuff, it was a little bit complicated where you had to calculate a remainder and an extra so that you knew what the strides were and what the length and the bound was for the SIMD loop, basically. But shouldn't be too hard to figure out. So yeah, that's the Sieve program in Cilk Plus.